All right, so we have some practice problems in writing scientific notation. A couple things we went over the basics of what scientific notation is. Now we're gonna take these are in standard numbers right here. We are gonna go convert those to scientific notation, and then on the second part we're gonna go from scientific notation to standard notation. So the first thing I always want to do is I want to find my first non-zero number right here. So that's going to be my 6. And then I always write 10 to the power of. Now my power of, I don't have a power of here, so I just do a caret to simplify here. So I need to count how many times I need to move this to get on this side of the 6. So I go 1, 2, 3, 4, 5, 6 here. I moved it 6 times. Now this number is less than 1, so I know that this needs to be a negative 6. If the number is smaller than 1, your exponent is negative, all right? So that's how I knew right away. If it's bigger than 1, it's going to be a positive right there. So let's go to this one, take a look. I first find my first number that is non-zero, which is going to be my 5. So I'm going to have 5 and then put decimal right here. So it's in the 1 spot. Anything left, so that's 4. And then I always have it times 10 to the power of, and then I count how many spots I need to move it. So this one is 1, 2, 3, 4, 5, 6. So this is 5.4 times 10 to the power of 6. All right, this one right here, 60, right? My decimal's right here. I need it to be behind the 6, right? That's my first non-zero number right there. So 6. I could put 0.0. It's not necessary, but you can. Times to the power of 10. It's always times to the power of 10. And then how many times did I have to move it? Well, I just moved it 1 in this case, right? So that's caret 1. 10 to the power of 1 is just 10, so 6 times 10, hey, that works out, that's 60, what we should expect. This one, my first non-zero number is 9 right here, so I'm going to put 9 times 10 to the power of, and I need that decimal to be behind my 9, right? So I'm going to move it 1, 2. 2 gets me to the 9, but I need 1 more to get behind the 9, so that's going to be to the negative 3 right there. 6.7. That already has a 6 in the 1 spot, so I'm going to go ahead and do times 10 to the 7th. I still need to do times 10 though, right? So 6.7 times 10. The power of, well, how many times did I move it? I didn't. So that's going to be to the 0th power here. You need to remember that 10 to the 0 is just equal to 1. So 6.7 times 1 is still 6.7. Here, this is going to be 2, right? Times 10 to the, how many times do I need to move it? 1, 2, 3, 4, 5, 6 gets me 2. 2, I need to be behind 2. 7, and that is smaller than 1, so that's going to be negative 7 right there. Okay, this one is 2 times 10 to the power of, and I count how many times I need to move this decimal here. 1, 2, 3, 4, 5, and 6. Okay, this one is a little tricky in that it looks like it's almost in scientific notation, but notice that is in the 10 spot. That's on the 1 spot. So the way I recommend doing this is first, just let's put this in scientific notation, the 71, right? So don't worry about the 10 to the 3rd for right now. 71, I know it's going to be 7.1, right? So I still need this in the 1 spot. Times 10 to the 1st power, because I need to move it over 1. I can't forget about this, so I'm going to still just bring it on down 10 to the 3rd here. Okay, now these are the same bases, right? 10 to the 1st, 10 to the 3rd. Well, what is 10 to the 3rd, right? That's 10 times 10 times 10 times 10, right? So this actually just simplifies 7.1 times 10 to the 4th, right? Because I have 10 times 10 times 10 times 10. Well, that's just 10 to the 4th here. What it turns out is if you have the same base, you can just add up these exponents. So when you have problems like this, there's a couple more like this. Go ahead and just do this part first, turn it into scientific notation, and then you can just add the exponents here because they're the same base. All right, 48900. So I'm going to go 4.89. I move my decimal over 1, 2, 3, 4. So that's going to be times 10 to the 4th. Okay, this one, my first number is 9 here. So again, we write 10 to the power of, and I see how many times I move it over. 1, 2, 3, 4, 5, 6. I have to go on the other side of 9, right? Because I want the decimal after it, so it's in the 1 spot. So that's going to put me, I believe that is 7. 1, 2, 3, 4, 5, 6, 7. And since this number is smaller than 1, this is negative 7 right here. Okay? And that will go ahead and give me 1 over 10 to the 7th. So that'd be 9 divided by over 10 to the 7th, which would go ahead and give me my right answer right there. Okay, this one right here. So I have 0.63 times 10 to the first. Again, this looks like it's in scientific notation, but this is in the 10th spot, not the 1 spot. So I'm going to first go ahead and convert 0.63 to 6.3 times 10 to the, and this is going to be the power of, I moved it 1, and it's less than 1, so that's negative 1 right here. And then I'm just going to bring this part down, so that's times 10 to the first. And remember, I can add up my exponents. So negative 1 plus 1, well, that's going to be 6.3 times 10 to the 0th power. Kind of canceling each other out there. But if I want to keep it in scientific notation, that's how I could still write in scientific notation. This one as well. Let's go ahead and turn this into scientific notation. So that's 3.3 times 10 to the, I had to move it over 1 time. It's bigger than 1, so it's positive. And I'm going to keep this one, so to the negative 3. Now there's the same base, so I can go ahead and add up my exponents, right? This would be 10 over 10 times 10 times 10. So I can cancel out 110. I just had 10 squared on the bottom. Or if I add up 1 plus negative 3, that's going to be negative 2. So right here, I got 2.16. That's going to be my base part here, times 10 my power here. And then we just count how many times we move this over. 1, 2, 3, 4. And that is smaller than 1, so that's going to be a negative 4. This one, my first number is 4, so I'm going to change that to the 1 spot. 0.2 times 10, and I move this over 1, 2, 3 times, right? And this is smaller than 1, so that's going to be a negative 3 here. 0.15. Okay, this is another one where it looks like it is because I have this times negative 2, but I'm first going to convert that. So that should be 1.5, so I have this in the 1 spot right here. Times 10 to the, and I made that, this is smaller than 1, so this should be negative 1 times 10 to be negative 2. Well, I go ahead and add up my bases right here. That's going to be 1.5 times 10 to the negative 3 here. My last one, 4.8 times 10. And right here, I didn't move it at all, so this just stays to the 0th power. So these are all examples of how I can go ahead and take it, a number in standard notation, and go ahead and write it in scientific notation. Now this one, I'm going to go the opposite way. These are in scientific notation, and I'm going to go ahead and convert these to standard notation. These, I think, are a little bit easier. We just need to go ahead and figure out which way to move the decimal. The exponent tells us how many times to move the decimal, and negative positive is just going to tell if the number is going to get bigger or smaller. So the way I think of it, negative exponent means it's getting smaller. So I just have to go ahead and move it to the left. That makes the number smaller. Move it to the right makes the number bigger. So in this case, this is a negative 1, so I move it 1 times. Negative means it gets smaller, right? So a 0.09 right here, right? If I move it the other way, that'd be 9. Well, 9 is bigger than 0.9. I need 0.09 because that is smaller than this 1 spot right there. Okay, same thing with it, right? 2, I want this to become smaller by 1 spot, so that's just going to become 0.2. So the decimal is right here. I moved it on the other side. 2 times 10 to the 5th, right? So this is a positive exponent. That means it's going to get larger. How many times? 5. I need to move that decimal 5 times. Well, there's nothing here, so I'm going to have to add 1, 2, 3, 4, 5, right? So the decimal is here, and I move it 1, 2, 3, 4, 5. It doesn't necessarily mean I'm adding 5 zeros. I'm just moving the decimal over, and if nothing's there, then I add zeros. Okay, 804 right here, and going to positive, so it's going to get bigger by 2 placeholders. So it's after the 4. I need to add 2 after that, so I move it over 1, 2. Okay, this is a good example right here of why it's not just adding the zeros right there, right? Because I have 2.66, right? I need this. This is positive, so it's going to get bigger. I need to get bigger by 4 spots. So I could put a bunch of zeros on here, right? That's not going to change it. And I just move this over 1, 2, 3, 4. So it needs to go right there, right? Because that's moving it over 4 spots, and it's getting bigger right there. So it's not, oh, notice right here, I get rid of this. I had 0.0. I can go ahead and get rid of that. That's not a big deal. Notice I have 10 to the 4th. I did not add 4 zeros because I needed the first 2 spots just to move over from the 6s. And then I needed zeros to count for those last 2 spots, all right? So you're just moving the decimal. If there's nothing there, then you add that 0. In this case, 1.5, I'm going to move this 2 spots, and it needs to get smaller, right? So if I got smaller 1, that would be 0.15. 1 more, there's nothing there, so add a 0. So 0.015. 7.75, again getting smaller by 1 decimal, so 0.775. 8.3, it's going to get larger by 7, so I move it over 1 right there. That gives me the 3. It's on the other side of the 3, and then I need to keep moving. So that's 1, 2, 3, 4, 5, 6, and 7 right there. So I should have 6 zeros, right? And then the last one I moved over was the 3, and so that's a total of 7 right there, right? So we can count 1, 2, 3, 4, 5, 6, 7. 9.5 times 10 to the 7th, similar method here. So I'm going to go ahead, 9.5, move it over 1, and then 6 more times. So that's going to end up being 95 million right here, right? It started out here. I moved it 1, 2, 3, 4, 5, 6, 7. 1.71 times 10 to the 7th. So I'm going to move it over 1, 2. In this case, instead of having 6 zeros, I'm going to have less than that because I already moved over 2. So this is 3, 4, 5, 6, 7, right? So I just added right there because I have that 1 right there. It's still, notice these are all 10 to the 7, 10 to the 7. It's still in the tens of millions, but I have another 1 right here where it was just a 0 that I needed. So zeros are only added to those spots that we don't have. 0.9 times 10 to the negative 3, right? So this is getting smaller, and I need to move it 3 times to the left then to make that smaller. So 1, 2, 3, 9, 3, right? It started before the 9. 1, 2, 3 over because it's negative, right? 2 means it's getting bigger, so 38. And I'm moving it over 2 to make it bigger. So move it over once to get bigger to 380, 3,800. Put a little comma there. 7.5 times 10 to the negative 5th. So again, this is going to get smaller. So if I move it to the right, it gets bigger. To move to the left, it gets smaller. I need to move it to the left then 5 times. So 1, 2, 3, 4, and the 7. That'd be right there. So that'd be 5 times. So 1, 2, 3, 4, 5. 4 times 10 to the 0th. Well, how many times do I move it? None. So just 4. Nice and simple. 8.4 times 10 to the 5th. So positive, it should get bigger. So 1 over the 4, and then 2, 3, 4, 5. That should be 840,000 right there. And then 4 times 10 to the negative 5th. Okay, so the decimal's right here. I'm going to move it to the left. That's 1. And then I do it 4 more times. So that's going to end up adding 4 zeros here with a decimal. We can always check that, right? So if I move it back, I moved it 4 times left. I go 1, 2, 3, 4, 5. I start with 4, but I'm making it smaller. So right there. All right. So hopefully you feel comfortable with putting it into scientific notation, also going out of scientific notation into standard. The key is you just got to think, is that exponent, right? Is it smaller than 1 or is it greater than 1? If it's smaller than 1, it's a negative exponent. Okay. If it's greater than 1, it's a positive exponent, right? Multiplying by that positive value there. And when you take it out, you're also thinking, hey, should this make it smaller or bigger, right? A negative should make it smaller than what it is. A positive would make it bigger than what it is.